In exercise 11G, we're going to look at the volumes of solids of revolution. Now, as its name suggests, we're going to be able to calculate the volume of a solid. And you may be wondering what that has to do with the calculus that we've been studying. Well, these solids are generated initially by a function, by a curve on a number plane. What happens then is that curve we have to imagine is rotated about the axis, and that will form our solid. If you take a look at this GeoGebra demonstration, oh look, hang on, I need to make it a little bit bigger, just a moment. I think that's better because I've made the actual frame bigger now. So what this section here is showing is if we draw, for example, the graph of the square root of x. So you're probably familiar with that. It's half of the parabola on its side, x equals y squared. So taking that curve now, we're going to rotate it around the x-axis, and that's what has actually happened here. Let me see if I can get that to move a little bit for you. So if I swivel this a little bit, you can hopefully see now, and because back here on this diagram I'm only taking the graph from say 1 to, what's that, about 14. Let me just change that. I'll change the, said 1.9. Let me go right back to say 0. Right. Oh, can I move it here? No, hang on. It's more like where I want it. So if we were looking at the curve from 0 to 14, and we took all the values of the function, rotated them around the x-axis, I'm just going to swivel it a little bit more, you can actually see that we generate this solid. It's a little bit of a what, like a pulled out, I suppose it's a cone shape. Now, to calculate the volume of the solid generated like that, then we go back to our calculus. And our calculus does it very nicely and very simply for us. There's a formula. And the formula is that the volume is pi times the integral from a to b, and I just spent all that time shuffling my a to trying to get it to 0. And b is your cutoff at the right-hand side of your solid, of the function squared. And obviously we're calculating volume, so the units will be cubed. I'll talk more about why that formula works when I go into our understanding of why the area formula works. I think I'll do both those deeper understandings a little bit later, after you've perfected the process. So this is one of these formulas that you have to learn. It has to be automatic, that you recall that the formula for calculating the volume includes pi, really important. And you'll see that where that pi comes from. It's really coming from the fact that the volume is made up by calculating the areas of circles. Then the circle adjacent to it would be a little bit smaller, and so on and so on. But it's basically about slices of circles. And like I said, that's as much as I'll go into it for now. Okay, we're just going to practice using the formula. And of course, we could be rotating around the y-axis. And you'll see when we do that, that we change our formula slightly. The pi stays the same. The limits a to b depending on the y-axis. But then it is the x squared function. So we've got to get our equation in terms of, make x the subject, so the function's in terms of the y variables, and we square the function. Okay, in this example,